Okay, let's go ahead and do a few more examples of integration by using the decomposition into partial fractions. Let's jump right in with our first example, and we get x squared x plus 2 dx. Now, as I said, when you have a repeated factor, it's going to be the linear right here is going to be natural log once you get that coefficient. The repeated, the x squared, is going to wind up being undoing the power rule. And so let's go ahead and see how that works. Multiply through, of course, by the common denominator. Let's go ahead and multiply this all out. It's 2b plus cx squared, and we get a plus c x squared plus 2a plus bx plus 2b, and we have 0x squared plus x plus 7. Now we can go use the Heaviside method by using x is equal to 0, but notice that I already have b. Okay, I already have b because there's only one linear, okay, and b is equal to 7 halves. Well, if b is equal to 7 halves, then 2a plus b is equal to 1, and therefore 2a is equal to, well, let's go ahead and subtract that. That becomes negative 5 halves. So a is equal to negative 5 fourths. And then if a is negative 5 fourths, then c is positive 5 fourths. Okay. Well, that means that the integral of x plus 7 over x squared x plus 2 dx pulls apart rather easily into negative 5 fourths over x plus 7 halves over x squared plus 5 fourths over x plus 2 dx. We get negative 5 fourths integral dx over x. That winds up being relatively simple. I get 7 halves integral x to the negative 2 dx. That's rather simple as well. And as you know, as I've done in the past, I'm not going to go ahead and integrate these, but obviously this is natural log, this is undoing the power rule, this is natural log. Tack on a plus c, and you have used decomposition into partial fractions as a integration technique of turning the integrand from something that is, icky, I guess, into something that is very, very usable and very easy to actually execute. Okay. Now the next one, let's go ahead and do, oh, that's a new one. Okay, let's go ahead and do that one. Integral of 10 over x minus 1, x squared plus 9 dx. Okay, now obviously the linear is going to give me a natural log. The irreducible quadratic is going to give me, sorry, I need to get a couple more pieces of paper. It's going to give me arctan. Okay, I just have to figure out what the coefficients are that correspond to those. And I have a over x minus 1 plus bx plus c over x squared plus 9, multiply through by the common denominator. And then multiply it out. Okay, and you're going to get a plus b x squared plus c minus b x plus 9a minus c, and that should be equal to 0x squared plus 0x plus 10. Okay. Well, let's go ahead and use the Heaviside method to actually find at least one thing. Let's go ahead and plug in if x is equal to 1. If x is equal to 1, then of course we're looking at this step right up here. We're going to wind up getting a times 10, or a is equal to 1. okay, because x is equal to 1 is going to turn this whole term into 0. Once we have that, we know that b, sorry, put a parenthesis on that one, is equal to -1. B is equal to -1, therefore c minus b is equal to 0 as well, so c is equal to -1, and I wind up having something rather straightforward, okay? So the integral of 10 over x minus 1, x squared plus 9 dx actually decomposes into 1 over x minus 1 plus, and actually we can go ahead and, no, let's leave it as it is, negative x minus 1 over x squared plus 9 dx. Now, here is the trick. Obviously, that first one, x minus 1, becomes that. What do I do with this next one? Because obviously the derivative of x squared plus 9 is 2x. I don't need that constant. Well, I can go ahead and pull that apart too, okay? And I have x over x squared plus 9 dx and 1 over x squared plus 9 dx. And then all I have to do from here is just provide a 2 and a 1/2. And I've pulled this apart. Once I'm done with the decomp, I might still have to pull it apart. And I get natural log of x minus 1 minus 1/2 natural log of x squared plus 9, don't need the absolute value bars there, minus 1/3 arctan of x over 3 plus c, based upon that formula that I showed you in the last video. Okay. Well, again, let's move on to the next example. And of course, if I'm going too fast for you, there always is the pause button. And we have x cubed over x cubed plus 1. Ruh-roh! Okay, well, there are two things that should actually bug you about this one. The first one is it's x cubed plus 1, so you have to remember the sum of two cubes factorization. The second thing that should bug you, though some of you probably didn't see it, is the fact that the numerator is of the same degree, and therefore division is necessary. But we can divide without dividing, if we really kind of put our minds to it. And we rewrite that numerator as x cubed plus 1 minus 1, so we can then separate the fraction into 1 plus a -1 over x cubed plus 1 dx. Now, of course, I can do plus 1 and put the negative out in front, and actually what I really want to do is I want to go ahead and we'll just decompose that. Okay, so what I have here is I have a over x plus 1 plus bx plus c over x squared minus x plus 1. And that, of course, is the factorization for the sum of two cubes, which I'm sure everyone remembered, right? No. Okay. Bx plus c times x plus 1. Now, if x is equal to -1, and I know usually I do this afterwards, but let's go ahead and get it out of the way. I get 1, and of course this whole term goes bye-bye, and I'm going to get -1 goes into here, and when it's squared is 1. 1 plus 1 plus 1, so that becomes 3a, or a is equal to 1/3, okay? So what I have here is I have 1 is equal to, and let's go ahead and just keep it as a while I'm doing my multiplying out and my recombination. But I'll turn it into 1/3 here in just a second. So I have a plus b x squared plus -a plus b plus c x plus a plus c. Okay. Well, I happen to know that that's going to mean 0x squared plus 0x plus 1 is equal to 1/3 plus b x squared plus -1/3 plus b plus c x plus 1/3 plus c. And therefore b is obviously equal to -1/3. So I have a, b, and I know that 1/3 plus c is equal to 1, and therefore c is equal to 2/3. Okay, let's keep moving. So what I have here is I know that's going to be dx minus the integral of 1 x cubed plus 1. We'll go ahead and put the dx up here. That means that it's dx minus, and of course the integral winds up being, put the 1/3 out in front, and we're going to have 1 over x plus 1 plus negative x plus 2 over x squared minus x plus 1. Okay, and then from there, what we're going to do is we're going to creatively pull it apart. Obviously, the first one doesn't need any pulling apart. The second one's going to need a little bit of finagling. What's going to be difficult on this is the actual using of completing the square to turn that quadratic into vertex form, such that you can actually perform the arctan. And that's actually going to take us a little bit of time, so I'm not going to do that right now. Suffice it to say, I mean, it's going to be, the arithmetic is just not worth our time right now. But basically, you would break this one up the same way we broke the one up with in the last video, last example, and you would proceed from there. Okay, I'm going to do one last example in terms of the decomp integration technique, and then we're going to move on from here. This one, of course, we need to at least get one example of a definite integral, and so we have 2x cubed minus 1 x squared plus 1 dx. Now, that is obviously going to need some division, okay? And I'll go ahead and I won't keep you in suspense. I'll go ahead and tell you what it is. It winds up being 2x minus 2x plus 1 over x squared plus 1 dx. Well, here again, we don't actually need to do decomp, but we are actually pulling things apart, so the logic of the decomp is still there. And so we have 0 to 1 minus, okay, 2x minus, and of course the 2x remaining over the x squared plus 1 becomes a natural log. Minus 1 over x squared plus 1 becomes arctan. So from here, you end up getting x squared minus the natural log of x squared plus 1, and we don't need the absolute value bars, I just put it there as habit, minus arctan x from 0 to 1. Okay. So we wind up with 1 minus natural log 2 minus arctan 1, 0 squared minus natural log 1 minus arctan of 0. Now all of that is 0 right there. And so what you really have is that right there is your answer. That's 1 minus natural log 2 minus arctan 1. And that can be popped into your calculator and evaluated. You know arctan 1, but of course natural log 2 is an irrational number that needs a little bit of calculator work. So that is decomp. I mean, it really does wind up being rather straightforward, especially if you've actually been exposed to the decomposition in the partial fractions before, which, if you're one of my former students, you have. From here, we'll go ahead and move on to the next couple sections, a couple videos for each probably, and then I will look forward to seeing you at the Skype session on Sunday. Bye.